the first question is, do I need to use the microphone, or are we good with that? Good with that? It's a small room, we need a microphone. So everybody, thanks for coming to the before lunch session. I love these because if I run long, there's not another speaker to yell at me. If I run short, everyone in the room loves me because they get to eat sooner. So can't lose either way. Let's see. So my name is Eli White. I'm CTO and founding partner of Musketeers Me, which you've probably never heard of, and that's fine, because the main thing that we do is we are the owners of the PHP Architect brand. So here's the tense question. How many people know about PHP Architect? Yay! To those that didn't raise your hand, yay, I get to tell you about this real quick. We are the only and longest running magazine/technical journal dedicated to PHP. We produce a monthly magazine. I actually have 6 copies up here if people would like to come grab them afterwards. We also publish books, we do online training, we do in-person training, and we run conferences. And if you're interested in speaking, our call for papers is open until tomorrow for PHP Tech, our upcoming conference in May. So make more work for me, submit more talks I have to review. So there's one thing I do want to do before I really get started here. This is my wife and also co-worker. Her Twitter handle is @CattyCreations. Today is her birthday, and I am here instead of spending the birthday with her. If you would, please tweet a happy birthday to @CattyCreations, and I would really appreciate it. So thank you. All right, so let's talk today about refactoring. The appropriate subtitle for this talk would be Eli rants for 50 minutes about why you should refactor and tries to slap you for attempting to rebuild. So I'm going to attempt to rant a little less, but I'll still rant. So really what we're talking about here, the core problem that exists is the attitude that people have of wanting to completely throw code away and rebuild it from scratch. Now, there's a number of reasons why this is good or bad, right? The question here is how many people have heard this statement? Someone comes in, this code base thing. How many have said it themselves? All right. So the real question is, for those in the front, everybody raise their hand. The real question is what really makes you think that you'll do better? What makes the person stating this think they will do better than the code that was already the code that was already written? The fact of the matter is that code does not rot, right? Just because code is old, there's nothing inherently wrong with it. Now there can be things wrong with it, but the fact that the code was written 6 months ago, or a year ago, or 10 years ago does not inherently make it bad, right? In fact, code that works is good code, right? Doesn't matter if it's code that works that's 10 years old and therefore it must be horrible. No. If it's working, it's good code. It's doing its job. Code's only job is to do a single task, whatever task that line of code has been given to do. Now, code that is broken absolutely needs to be fixed, right? You need to go in and fix that. The real fundamental problem here are new programmers coming in. You hire someone new to come in. They walk up and they look at the existing code base. You go, that looks like crap. And therefore, it must be rewritten from scratch. This is actually a monument somewhere. I have no idea what. It's amazing what you can find on Creative Commons on Flickr. But the fact is, they look at it, they don't understand the code that exists, and therefore declare, I have to rewrite this from scratch. This is obviously horrible code. The programmers that came before me obviously did a horrible idea. The reason that this happens is something called Joel's Law. Specifically, Joel Spassky's fundamental law of programming. And it reads simply this. It is harder to read code than to write code. And that is, whether you agree with that statement or not, although I see most people nodding their head, it is a fundamental truth, right? For a programmer, what you are trained to do is to write code. What you do for your daily job is you write code. Reading code that, and this is not just code that someone else wrote, this is also the whole why commenting is good, and I have a whole other rant about that. But try to read your own code from 10 years ago. And you're like, who the heck are, oh wait, the commit log says it was me. It is just simply hard to write code, because code is not nearly as expressive of a language, it's a much more formulated language than English, for example, than any modern language we use for communication. And because it's harder to read it than write it, it makes people come in and look at it, and therefore they would rather write their own code that they now understand because they wrote it, rather than to take the time and to do the harder task of reading the code and understanding what it's doing and why it's doing it. If you're not familiar with Joel Swansky, I highly recommend you do go to his blog. It's joelandsoftware.com. He's a programmer that's been with a number of large companies in the past and started blogging with profound things like this, and it is well worth losing a weekend to reading all of his back articles. So there's a number of reasons why refactoring is better and why rebuilding is bad. One of them is the fact that that current code base you're looking at, that's really ugly to your eyes, there are millions of bug fixes that have been applied to that code base, right? Part of why it looks that way is that the original code that was written was very pretty, it was beautiful. Whoever wrote that first thought, at that moment, it was beautiful, perfect code. And then someone found a bug, and they had to fix it. And then someone found another bug, and they had to fix it. And that happened over time. And now it doesn't look so nice anymore. But the fact is that that code has all of those bug fixes in there, right? When you rebuild from scratch, you lose all of those bug fixes. Now, your new code may not have that same bug, or it might. It might introduce new bugs. In fact, it will introduce new bugs, because it's pretty much impossible to write code without introducing bugs. I think that's like the third fundamental law of programming. I wrote code, therefore there will be a bug. There is also in general a dislike of complication among programmers. Again, this all comes back to that it's harder to read than to write. When you're writing code, if you happen to write complication in, it just happened because that's something you need to do. When you're trying to read code and you see really complicated things and things you don't instantly understand, it bothers us inside. So people see a 2-page long function, right? And they see, it's nasty, hairy, long, fragile code. There's weird bits you don't understand, and you don't know why. And it may actually have, I know I've done this before, that comment that says, do not change the line beneath this. Or worse, I've actually had the comment that says, do not move this comment. Back in the days of C compiling, sometimes a bug in the compiler got fixed by having a comment on a certain moment. And no one knew why, but there was a comment, and if you removed that comment, the code broke. Put the comment back in, it worked. You just crossed your fingers and left it in and moved on. But the fact is, there's always a reason that that complication is there, right? And in this case, you look at this, obviously the plumber who did this must have been crazy. But the fact is, I do not know the reason, but there was probably a really good reason why the plumbing needed to be run like this. There's probably 6 independent bathrooms that just happened to be next to each other, and they all needed their own way to go. And it ended up being totally outside of the building because it was a retrofit after the fact. Who knows why, but there was a reason that was done. It didn't just happen because someone had extra L brackets or L connections and wanted to use them all. No one does that. The fact is that complication can be good. Because every weird line of code, every WTF that you see when trying to read someone else's code, is typically a bug fix that happened over the years, right? It's something that got put in there because it was needed over the lifetime of a product. In the end, that horrible looking function is actually an amazing function because it's battle hardened, right? It's been well tested, it is solid, it is doing what it needs to do. And again, I'm not talking about a case where there is actually a bug or a problem in that function and you have to go and fix it. I'm talking about the function works perfectly fine, but it just looks horrible. I should rebuild this, right? I have a good example of this. Here's where I get to date myself and maybe part of the room. How many people remember the original dig.com, not what it is today, which is the best version? A few of us. I was programmer number 2 at dig.com. You want to talk about learning to deal with scale suddenly. I started at Dig when there were 30,000 users. By the time I left, there were 30 million. And we were doing like things on the order of magnitude of 10 million page views a minute. Just crazy stuff. So there was one function here. There was a function that I happened to, somehow it became my function, because I was the one that had kept modifying it over the years because it was needed. And it was the login function. So if you went and logged into Dig, there was this one function that was like this long. It was horrible. It was ugly, I fully admit it. That did, if you think about your typical login function, there shouldn't be much complicated to it, right? You pass in a username and the password that the user entered, and it just checks against the database, does a hash and checks it, and returns true or false. Not quite the case at Dig, because there was a lot of extra stuff that got baked into this function over the years. For example, we took into account remember me cookies. If you had said remember me, and so this function got called to log you in whether you went to log in or not. This one same function got called on any page request when you weren't logged in to see, did this cookie exist? If so, let's try to log them in with the information stored in. It also did stuff like dealing with the fact that there was only one account on Dig that people tried to hack, and they tried to hack it every couple seconds. That was Kevin Rose's account. So we did things like Kevin Rose's account used a different salt and a different hashing algorithm. Kevin Rose's remember me cookies used a different salt and a different hashing algorithm, and randomly changed every week so that he got force logged out every week. But he was okay with that because it made it harder for his account to be hacked. And this function had to handle that. There was also really weird stuff in this function, because it turns out when you're dealing with stuff on the scale of like 30 million page views a minute, those weird things that, that'll only ever happen once in a 10 million chance. That happens all the time at this level of scale. So there was this one bug. This bug was like a year of my life. Not that I spent a year working on this one, but it took a year to fix this bug, because we would, once a week, get a report in from users that they had this weird thing where they logged into the site, but then when they went to click on any of the buttons to dig a story, which for those not familiar is the equivalent of thumbs upping on Facebook. Okay? So when they went to click a button to dig a story, it would pop up this weird error to them about there has been a disturbance in the space-time continuum. That was the actual error message, which I wrote because that was code for a session hijacking attempt has been detected. But we don't want to put an error back to people saying, bad person, stop trying to hijack sessions, because you don't want the hackers to know you caught them. So there was this cryptic error that if a user reported that to us, we knew, that's what happened. But these were legitimate users making legitimate requests. And I tried forever to try to track down this bug and figure out what was going on. I could not figure out, I could never reproduce it. In fact, the people who experienced it could never reproduce it. It would happen once, and the few that would talk with me and get an email thread going, they could never reproduce it. I looked in the logs, it was horrible. Until one time I was in the Dig office, because I worked remotely most of the time, and our administrative assistant, who was also addicted to the website, and became a great tester for us because of that, went, hey Eli, I just had this weird thing happen. I went, really? And I ran over to her desk and saw that the exact same thing had happened, and she couldn't reproduce it. And I went, okay, wait. So it was her first thing she did in the morning, and this happened. And I'm like, when does this happen? She's like, you know what? It actually happens to me every morning. I just never bothered to report it. And so we still can get happy again. So I'm like, okay, shut down your computer. Let's pretend you're just, like, literally stand up, walk away from the desk, because nothing was working. Pretend you just came in the morning. And she went, okay. She walked in. She sat down. She logged into her computer. She launched Firefox. She right-clicked on her Dig bookmark folder and said open all in tabs. 12 concurrent requests to 12 different category pages fired off to Dig. 12 remember me cookies tried to log her in at the exact same time, and a race condition happened. Whichever request finished last that was now the session that was sent back to her browser, and the session that her browser thought she was operating under. Those 11 other pages that she opened thought that she was on a different session with a different CSRF token. And so every click on those pages was seen as an attack attempt that was being thwarted. So therefore, the logging code got this much more code added to it, so that it actually did locking. So as soon as one request to log you in started happening, it actually wrote a key after memcached to say this user account is attempting to log in at the moment under this process ID, and then any other request that came in would check that lock, and it would sit and spin and wait for that lock to be relieved. And that lock got relieved by writing its session ID that it used back into it, so that every other attempt to log in would now just say, oh, I'm going to change my session ID to that session ID, and all mirror the same session, and it fixed it. It was a mess. But the moral of the story is this was an ugly function, and I fully admit it was horrible. And it became the thing that every single new hire today that came in, as they were learning the code base, they would see this function. You could audibly hear a shriek of dismay. And I knew within 3 hours there would be a pull request kind of thing, where they're like, I'm going to rewrite this thing. And every single time someone tried to rewrite it, it didn't meet 5 or 6 of the weird bug edge cases that we had found. And in the few cases where someone went, okay, wait, no, I'll make this work. And we would point them to all the various bugs in the past, and they would go through there and they would, okay, it's now working, it handles all these things. The code would be identical to the code that so sometimes hairy, ugly functions are there for a good reason. The other issue is an issue of lost time, right? It takes a lot of time to rebuild something from scratch. During that entire time you're rebuilding something from scratch just because the code looked ugly, you could have been building other things. Realize in the end, whether you're a business owner or just a programmer for a business, the business exists to make money. Typically the businesses are making money by making products or by selling the services. The time you're spending doing that could have been spent making a new product or making your current product better. You could have been putting new features out, and all of that time gets lost. And there's a perfect example of this. For any of us also with enough white hair to remember this browser. It was called Netscape. It was in the heyday of the internet, Netscape 4 was the browser everyone used. There was this little startup, probably no one ever heard of, called Microsoft, that had this browser called IE that like nobody used because it was horrible. It was truly horrible. And Netscape decided at version 4, they actually got acquired by AOL. And AOL took a look, the AOL engineers took a look at the code base, declared it crap. And we're going to rewrite this from scratch. And they did. It took them 3 years. There were no new versions of Netscape for 3 entire years. During that time, other browsers, such as this little startup Microsoft, kept iterating their browser and adding new things. And they made it not only on feature par with Netscape, they started adding new things that didn't exist. People started building websites now that were optimized for IE because they wanted to use those new features. So 3 years later, when Netscape 6 came out, by the way, you'll notice they went from 4 to 6. This was not a PHP 5 to 7 issue of a failed attempt. This was during the time that Netscape 4 got to be released in the next version, IE released version 3, 4, 5, and 6. So when Netscape went to release it, they didn't want to call theirs 5 because people will think we're behind the times. So they named it 6, yet it was still behind the times. Netscape 6 had the exact same feature set as Netscape 4. It was just now recoded from scratch to be better, and nobody used it. The world had moved on, they completely lost their market share, and so they ended up, AOL ended up saying, screw this was a horrible mistake, and they open sourced the software, which is now what is known as Mozilla and Firefox. However, the open source community made the same mistake. They took a look at Netscape version 6 codebase and went, this is crap, and rewrote it from scratch. And it was 2 to 3 years after being open source that the first version of Mozilla came out. And during that time, now granted, it has a great, wonderful story that now it's a very popular browser, and there's a lot of popular browsers, but Netscape 4 went from being the dominant browser to just completely losing the market because of this. I have another example from my own past. I worked for 7 years for the Hubble Space Telescope program. I was in the Department of Public Outreach. We were the people who, every pretty picture you have seen that the Hubble has taken, it was our department that went through. I know the guy and the one computer that every image went through, and it's his version of Photoshop that puts them together. He used the constructor of all the images you see. We had this interesting issue. We had a press release. We had been releasing press releases for a long time. At this point that this project started, it was 2004. Hubble had been putting out press releases since 1994. Somebody there, it was actually that one guy, who's the guy who has processed every Hubble image ever, thought, there's this new web thing in 1994. It'd be cool if I took these images and put them online. And he managed to get a desktop computer set up online in the Hubble offices. And he started making these web pages where he was just taking the image, which was already digital, because everything that comes from Hubble is digital. It's not like a print gets mailed from space. So he took the digital image and put it up, and he would copy all the text from the press release and put it up, and hey, it's up there. And he started doing that for every release. Well, that was 1994. It was now 2004, and over the years, press releases got a lot more complicated. Now, a press release had multiple images. It might have video. There would be 12 versions of copies. There would be the copy through the K through 4 crowd, the copy for the secondary educators, the copy for college, the copy for CNN to use versus the public information, the scientific information, special zoom-in things. Press releases got super complicated. And over the years, we had 10 years of these. These had all been created by hand. They were just HTML files, and the look and feel of them had changed over the years as new things were added. So we had this pile of 100 press releases a year for 10 years that were completely unorganized, and we wanted to get them into a database so that we could make a unified look and feel and be able to do things like show me all press releases about the Crab Nebula and to be able to get all those back. So I got tasked with making this database-like thing. And I put it in quotes because it actually wasn't a database originally the way we put it together. It ended up becoming this very highly organized file system where there was a title.txt file that had the title of the press release in it, and a copy.txt, and then all the images, and we would be able to programmatically build a view by looking through this directory system and pulling all this data together. But the thing is, this project took almost a year from the time we started Singling to do this to actually getting it live. And the biggest issue was the fact that we were trying, I say we, it was me, trying to do this as one huge chunk, one huge project, right? It was like, we're going to take all of this data over 10 years, and we're going to data entry and pull it out and organize it into these separate fields and rename all the images, and then build the software that will look at that, and then build the software that will allow new ones to be made, and then build the software that allows us to show all of these. And it's going to be great. And it kept stumbling because it was such a huge project. We would get to points where I was going on 2-week vacation, and 10 people got tasked to do data entry. It was ready for me when I got back. And I got back and found out they did 0 because everyone was busy. And during this entire time, part of the whole reason we were doing this project was that there was this one poor lady who was officially a programmer. However, her entire job was spending 10 hours a day assembling HTML to put in these press releases. As soon as one was done, another one came to her. And she was just constantly assembling HTML, making this happen. And we needed to stop that. This cannot scale. Either we have to hire a second person to assemble HTML, or we need to solve this. And so her life became worse for that entire year. Because now, press releases were still happening during this year that we were trying to get this massive project done. Every week that we went without getting it done, 2 more press releases appeared, making the job even harder. And it just snowballed to the point to where finally it got to the point where we literally told the news department, you have to give us 3 weeks or you cannot release a press release. And we took the entire department of 50 people and put them all on data entry. And every press release had to be data entry by one person, reviewed by 2 to make sure it was all right. And it was just this horrible, horrible thing. And in the end, it was this great system we had. but because it was this huge rebuild of the previous process. In this case, it was a process, not even software. It had all of these problems with it. And I'll talk more about that in just a little bit. But there's another major issue that can happen when you're doing a rebuild. And it's the idea of a product never shipping because the rebuild simply takes so long. Similar to that previous example, spent a year trying to rebuild this one whole process of how press releases were put together. And then you spend so long, again, we talked, businesses are out to make money. They need to make money to pay your paycheck. If the entire development shop shuts down for 3 months to try to rebuild something and no money comes in, that can bankrupt the business, or that can at least cancel a project. There's one super big public-facing version of this, but I bet a lot of you don't know this. If I say the word Microsoft Pyramid, does that ring a bell to anyone? Microsoft has done such a good job sweeping this under the rug. There was a project at Microsoft called Pyramid. It was going to be the replacement to Word. Basically, they had hired in, it was the same situation, they had hired in a bunch of new programmers to work on the Word team. They looked at the code base and went, oh my God, because the Word code base had started back when it was a text editor for DOS. And now it was running in Windows, whatever version this happened. It may have been Windows 95, I don't remember how long ago this was. But they were like, we need to rewrite this thing from scratch so that it'll be better and allow us to add more things in the future and to be able to maintain it. And they convinced their bosses, a project got created called Project Pyramid, and this entire team of developers were put to it to rebuild Word from scratch. This sounds awesome. They spent 18 months doing that, still did not have a feature-complete compatible product. And the entire project got scrapped. Microsoft just pulled the rug because they had 50 developers making six-figure salaries working on this for 18 months, and they could not see where the end of the tunnel was. And so they scrapped it. Luckily for Microsoft, Microsoft is a gigantic company with a lot of money, so to them it was a bit of a financial hit, but it wasn't like the company folded. Also, luckily, Microsoft had so much money that they were smart, and they didn't stop development on Word for those 18 months. They made this entire new team. The original Word team was still working on bug fixes and making new features on Word during that time. So it didn't actually impact the main Word project itself. Another issue you can have, which directly came off of that, is loss of functionality. Typically, when you're going to rebuild, because it's such a big process, you tend to aim more to hit MVP again, minimum viable product. You tend not to try to be exactly feature complete. But then what happens is you release that brand new MVP, and all of your customers, all of your users, start complaining. Because while this one feature is only used by 0.1% of the users, that may be true, but you have enough of those. And suddenly every single user had one feature that to them made or broke the product and that they were used to using, and now that's not there. And then by the time you quickly scramble and try to put all these features back in, and you get it back to feature complete mode, the code base looks the same. It's in the same state. It's an ugly, hairy mess. There's a number of good examples of that. One of them is the software I'm using right now. When Apple released the iWork version 6 a few years ago, all of the apps, not just Keynote, but all of the apps were rewritten from scratch, and half the features were gone. So to all of us conference speakers, the ability to adjust your Keynote, your presenter display, what size your, how big your text box is and how big these are, was removed. And that was something that basically every presenter used to customize that to how they like to present. In Pages, their word processor, they removed the ability to do mail merges. In fact, they still have not added that ability back in. And when you read their actual FAQ of how do I do a mail merge in Pages version 6, the response is use Pages version 5.3, which is still installed on your system because when you upgraded to 6, they didn't delete the old apps knowing they weren't feature complete. They copied them to an old folder. So you can still get to them and use them. So still to this day, if you used to do mail merges using iWork software, you have to launch the old version of it to do that. It doesn't have to be features in the common sense as well. I have worked lots of weird jobs. I worked a year for the NSA, building firewall software for the NSA. I can actually talk about it, even though that work was under top secret, because this was the one time, as far as I know in history, that the NSA approved a company, the contractor that I was with, to make a project for the NSA to also make a commercial version of that product, which was called Cyber Shield, which you never find for now. It's called, it never sold. But the real work, bulk of the work I did was on the Cyber Shield side, the commercial side, because we would basically build everything for the commercial side, and then they would pluck that out and put it into the NSA top secret version. And here, the functionality that was lost was performance. One of the big tasks I had there was, so part of this firewall, it did tons of stuff, and the big thing I was working on was a web filtering system. So if someone inside of the NSA or anyone behind a Cyber Shield firewall, if you launched a web browser and tried to go somewhere, it would go through our machine. Our machine would see the request coming through as a proxy. It would launch a single instance of Apache just for you in standalone mode, and would use Apache as a proxy to proxy the request on, get the data back, and then run like 20 different filters, so it's configurable which filters you wanted, on the data before it returned it to you, or chose not to return it to you. It's like one of the filters was, look for the word top secret. If so, don't return it. Because of course, everyone who puts top secret info out is going to market top secret. Didn't say they were super smart, but they were paying the bills. But there was a lot of stuff they did. Like it ran a virus scan on the page that was being requested just in case it wasn't HTML, it was actually exe. This was back in the days when JavaScript banned, cookies banned. So it tried to strip every JavaScript out of the page. I had a regex that long that would try to attempt to strip all 1990s-based JavaScript out of the page and still have the page work. It scanned the headers that were coming through and removed cookies so that no cookies could come through either direction. It scanned both modified stuff going out and coming back. I also had to write a pornography filter that would attempt to block any website that had pornography on it. Most interesting testing job or assignment that you get. We had a special room where you had to go when that filter needed tested. You would browse in images off mode in the browser, but you would have, your job at that point was like, your job today is, can you get a porn site to load through our filter? And when one loaded up, you had to now document the URL and submit it, and I would get those bug requests. And I would now have to go and load up that page to see why that page got through my filter and add new keywords into my filter to try to stop that page from happening. We are being paid by the NSA to look at porn pages. So what happened here was that the way to make this work, there's all these filters being run, and this is the web. People are expecting quick requests out, quick requests back, right? This needed to be fast. I tried 20 different ways of factoring the code to make this work. The one thing I found that worked, and that made requests be snappy, was sort of using Unix the way Unix was meant to be done. I had all of these filters, though they were turn on or off configurable as separate EXEs. And I would, in my code, launch separate processes for each EXE, hook their input and outputs together as one big long pipe. And then I would send the data in one end and start waiting on the other end to read back out. So as each filter went, each filter processed line by line. When one finished one line, it passed it on to the next filter and it could start working. And so all of these were working in parallel and it made it work fast. The problem was that the senior engineer or senior architect on that project, who had not written code in a very long time, but was the architect, noticed that whenever you would run this on the system, the CPU would spike to 100% usage as you were requesting a page. And he declared that this is a horrible concept. The CPU should never hit 100%. I had to point out to him that we're doing the most complicated stuff you possibly can in 1996 technology here. And there's not that much CPU on this machine, and yeah, it's going to hit 100% because it's trying to use as much CPU as it can to do it quickly. But But you'll also notice it hits 100% CPU for like half a second and then it's gone because the request is over. But he didn't want to believe that, so so after months of arguing, him arguing and saying it had to be done a different way, and me showing him all my previous examples and how it didn't work, he ended up tasking someone behind my back to go and rebuild that from scratch, and obviously horrible code. And she did, and she made really beautiful code. She showed it to me afterwards, because she's like, I feel really bad, this way things went, but he's the boss, he told me to do it. I'm like, it's fine, let me see your code, I'm curious. She showed me the code, it was exactly my original code I wrote, where it was doing them one at a time. You know, all within, let's run this, let's get the response, let's hand it to this one, let's get the response. Doing them in serial, and it got pushed to production, and every single customer complained, because now every request on the web was taking like 5 seconds, because it was getting slowed down that much. And in the end, they reverted the code back to the original code, and all that time was lost. So the question here is, what should you do, right? Are you scared, are you confused, like rebuilding, refactoring? Should you never rebuild something from scratch? Probably not, but there are times things do need rebuilt. So how should you rebuild it? And that's where refactoring comes in here, right? What you need to do is break up the project into small, discrete parts. Don't do it all at once. A great policy to have is if you touch it, fix it. So you have a huge code base. You have thousands of classes, millions of whatever, millions of lines of code. If something's working and you don't have to add functionality there and there's not a bug there, you leave that code alone. But if you get a bug request, if you get a feature request, if you're going in and changing a section of code, well, while you're there, go ahead and clean up and refactor that section, right? Make it better piecemeal as you go. The trick here is to come up with a way of making sure that you always have a working product, right? You never just shut everything down for 3 months and then come back up with a working project. Keep it going all the time. I mentioned Digger. One of a great example of this, which I did not do, so I'll give all credit where it's due. There was a new programmer brought into the Dig project. Actually, there was a bunch. For a long time, there were just 3 of us. There were 3 programmers there for a year and a half. All of us were senior programmers. I was the least senior. The most senior had started programming on punch cards and was now writing Dig. So I felt, I was like, oh, that's okay. I will listen, whatever you say. So we started hiring a bunch of new programmers, and they started legitimately gacking when they looked at the code base. Because this original code base of Dig was not MVC. It was mixed together HTML and PHP code in gigantic 20,000 line files. Or 100,000 line files. It was just, like your user page was one, 80,000 line file that handled rendering out your user page with mixed in HTML stuff. Every file began with include utilities.php, include database.php, instantiate the database, start the session. It was really old school PHP. A lot of that was because Dig started as a $1,000 contract that was going to be a one-off thing. It was actually done on plants.com. It was just this, I just want this website that does this, and the person only getting paid $1,000 to do it, okay. And made the simplest thing they could and took their $1,000 and moved on. They got hired. But what these new folks who came in did, one of them in particular, who went on to become the chief architect of the software for Dig for a while, he's like, okay, we want there to be an MVC. We recognize that trashing it all and writing it from scratch would mean no new features on Dig for 6 months, because Dig was this huge thing, complicated, fragile thing with algorithms and everything touching everywhere. So what he did was he built this very simple MVC framework. It was a micro framework by today's standards, very basic. Even it had no routing based in it directly. To route things to it, you had to edit a .htaccess file and actually send certain requests into it via that way. And the very first commit that happened was just pushing this one class file out that made this baby micro MVC look, this MVC exists. Nothing's using it, but we've tested it, we're pushing it out there so it's ready to be used. And then a policy was put in place. Any new feature that we're creating uses the MVC. And anytime you have to go and update a page, if that page is not using the MVC, part of updating it is you refactor that to not be the one monolithic page, you jam it into the MVC. And it can be a piecemeal. Like if it's a big monolithic page, I'm just changing this part. You make that part be its own folder and view, and you make the monolithic page just call into the MVC and say, give me that one view, and you factored it out slowly. And then what happened was over the course of a year, I think, give or take 6 months, they slowly got refactored into this MVC, and the MVC started getting extra features added to it and growing. And at one point, we got down to, about a year later, we realized that there were exactly 2 URLs on the entire site that did not use the MVC. And we looked at them and realized one of them was a legacy page that the management said, we don't need that anymore. So we just shut that page down. And so there was now one page left. And so we actually put the only one ticket that existed that just said refactor that into the system. And someone went, took a day, refactored that one thing, and now the entire system is under MVC. And we never shut down. It was constantly up, and new features were being added the whole time. I have another example of that from my current company. I said we've been around for 13 years. I have not been doing PHP Architect for 13 years. I've been doing it for 3. Because my parent company, Musketeers Me, we bought the brand PHP Architect 3 years ago. We had been huge fans of the brand. We had gone to all of the conferences. We subscribed to the magazine. 3 years ago, we heard through the grapevine that the previous owner had gotten burned out and was going to just shut the whole thing down. We all went. We feel that's a really valuable service to the community. We think that that should still exist. We ourselves had just founded as a consulting group only 3 months before that. So we went, and we took all the money we made for those 3 months and threw it at the guy and bought the brand, signed contracts, and now we do PHP Architect. And at the time, we still had contracts going, and so I was the one who's basically like, Eli, you're in charge of figuring out the software and getting running on our own servers and getting stuff working. And I looked at the software and I gasped. Partially because it was written in PHP 4 originally, but that's a whole different story. But the fact is, our entire interface, which now I like and it's cleaned up a lot, we have a web service API layer that runs, and then we have multiple different front ends that all use this API. We have an Air app that we use for administration. We have an iPad app that you can download and use to look at your magazines that you subscribe to. We also have our websites, which actually all run WordPress, and have custom plugins written that talk to our API and then format things back to WordPress. The big issue was that all of these were written for WordPress before WordPress 3.0, i.e. they were written before a good framework architecture and plugin system for WordPress existed. If you're not really deeply familiar with WordPress, version 3, and they're now version 4.4 or something, but in version 3, they introduced this really robust plugin system that hadn't been there before, that really allows you to use WordPress as an application development framework. All of our code was written before that, and so it was using the really hacked ways of doing it that people used to do, where you would like have a random URL that wouldn't get captured by WordPress and send people to, and then halfway through your code, you bootstrap WordPress into your PHP, halfway through your PHP. Don't do that. But it's how people did stuff back then. And so, again, over time, at the time, it was like, I just need to get this up and running and make it work. And then purely because there's only 5 of us and we have no time, because we're producing a monthly magazine and running 3 conferences a year. Books, I didn't have time to do a let's tear it all down and build it from scratch. So what has happened is over time, we have refactored each one of those plugins as we needed to update them and made them actually modern WordPress, modern style, and everything is much cleaner now. All the hacks are gone. I talked before about the Hubble press releases and how horrible that project ended up going. The question therefore remains of how could that have been done better? And how could we have helped that one poor person who was doing 10-hour days every single day, trying to get these up instead of making life harder for them? And again, this comes down to having cherry-picked things we could have refactored easily. Like we could have said, at this point going forward, here's a standardized directory structure and a standardized how to name things that will make it easier on us in the future. And from this point forward, just start doing that. That wouldn't have taken any extra effort on our part. She was already copying things and making links and putting each one by hand. Just giving her a standardized way to like, put your images in a folder called images, name them 1.jpg, 2.jpg, 3.jpg. Like, that would have been a huge thing that would have helped automation later, just to have her start doing that. We could have then built a reader for that that would start for newer press releases, assembling them off of that data. And suddenly, the main issue of why we were doing this would have been fixed. It wouldn't have taken her an hour to put a press release together. It's copying and pasting a couple files instead of trying to format HTML. This is before CSS, so this is bad formatting HTML. We could have fixed the press releases moving forward. And then we could have augmented that and started making like XML files to hold the titles and descriptions and all that. And then, after she was spending an hour a day instead of 10 hours a day, well, now it would be easy for her to start going back through time and modifying the old ones to this new format. And slowly over time, everything could have been using the new software. That would have been a much better thing. Really would. So, to recap here at the end, if you're talking about rebuilding, rebuilding by definition will come with a loss of time. It has a risk of losing functionality. It has a risk of the market moving up beneath you as you're losing that. You will lose all of your bug fixes. And 99% of the time, and I totally just made that number up, you will end up back where you started by the time that you rewritten that. These are just some examples I gave you. I've seen numerous others. By the time you have rewritten it and got it back to feature parity, got it back to being bug-free, it's going to be its own new version of that's an ugly code base when the next person who comes in and builds it. Because the ugly parts are the things you fixed. Everyone tries to make pretty code in the beginning. If you refactor, however, refactoring is about making those incremental gains, picking one small part and just fixing that. The entire time keeping your code functional. Never having to go to your boss and say, you know, the whole thing's going to break for 3 weeks and then it'll be better afterwards. Updating as you go. And a lot of this is about being agile. And I mean agile with a small a, not a big A bad small a. But just being agile, being able to slowly work with refactoring. Yet in the middle, suddenly, the market says, wait, business says we have to do this thing instead. Being able to go, okay, and stop what you're doing, and go make this new feature that you need to make all of a sudden. And not being halfway through a 3-month-long rebuild, and suddenly finding out that the company's going to fold if you don't do this now. That happened back when I was at NSA, where I'm safe to say pointy-haired boss, because his hair actually looked like the older boss's hair. Would like literally at one point, he flew to Japan to talk to some potential clients, spent a week there. He came back, and Monday morning, he came into we all worked in a big war room on this one project. He came into the war room, and he's like, hey, by the way, everyone, I was just curious. Is it possible to redo our software to have it have translations for different languages, like all the error pages and login pages? You know, be able to do that? And they're like, yeah, sure. Yeah, we can totally do that. It's like, okay, great, but how long would that take? And we're like, well, with everything we're doing and all that, you know, it's like 3 months would be safe. We might be able to do it in 2 months. He's like, okay, great. I promised it on Friday. He had sold like a $500,000 contract, and we had to have it translated into Japanese by Friday. So thank you all very much. Thank you for listening to me rant. This presentation will be uploaded to my website, eliw.com. I'll also link it from the Joined In page. Please do rate me and all the speakers on Joined In. Speaking as a speaker, I absolutely love getting any and all feedback. It helps me in any future presentations that I do. Putting on my other hat as a conference organizer, I absolutely love all the feedback that is given because it helps me as a conference organizer know how well a conference I ran went. It also helps me evaluate speakers I have never seen before, submit to my CFP, which is a handy thing. So thank you very much. Are there any questions? We have 9 minutes to lunch. Sure. We built it by Friday. Yeah, it was not pretty. It actually, instead of it being a nice generic, using get text, if you're familiar with that and all that, like translation system, it was instead hard-coded switch. Everywhere there was text, there was a English versus Japanese with a switch you flip in the config file. And we had no idea, like, part of the deal, at least that the boss had done, is he did at least agree that someone on that company's team would be our resource for the translating. So we were able to, basically, we ran a grep to pull every string out of the software. This was all written in C. So we did a grep that pulled every string out, and we emailed that to this one person. On Wednesday, we got this email back to us. We then had to learn what UTF-8 was. This was a while ago. Because suddenly, like, why are there all these square boxes everywhere? When I was and yeah, literally, we went through the entire, to get something working by Friday, we just went through the entire code base where we pulled all those strings out. We now knew what line each of those were in what file. And we went into that line of file and we had a global variable for language. And we did if global English, move the line, if global Japanese, put this line. And it was so happy, and it was working. And after that, we actually spent time refactoring that when we had some downtime. Did it properly. And as our test case, made a pig-like version. So that we could, anytime the boss was using the website, we could put it in pig-like. Anything else? All right, well, thank you all very much.